Good morning, children. Welcome back to our maths session. Today's topic is Introduction Part 1 and Exercise 14.1. Today we are introducing new chapter Factorization. It's a continuation of chapter number 9 Algebraic Expressions and Identities. So let we start. So, let's start our new chapter, that is chapter number 14, Factorization. The topics to be covered in this chapter are Introduction, Factorization, Method of Common Factors, Method of Regrouping Terms, Factorization using Identities, Factors of the form x plus a into x plus b, and division of algebraic expressions that are monomial divided by monomial, polynomial divided by monomial, polynomial divided by polynomial. So let's start our introduction part. So, what is factorization? Factorization means finding factors, right? A very simple term which means finding the factors. Now, all of you know what is a factor? It is a number which can exactly exact divisor of a particular number, right? For example, if you take a number 6, so which are the numbers which are exactly divisible of 6? That means which are those numbers which can divide 6 completely. So such that a remainder would be 0. For example, 1. So if you 6 divided by 1, what do you get? You get 6, right? There is no remainder. So let it be 2. 6 divided by 2 is 3. There is no remainder again, right? Similarly, 6 divided by 3. The answer is 2. Again, there is no remainder. So 1, 2, 3 and 6. These are the factors which are exactly divisible by 6. Therefore, these are factors of 6. Now think of any other example. A number 12. 1, 2, 3, 4, 6 and 12. These are the factors of 12. Again, you can very easily find out the factors, right? Same way, what are the factors of 28? 1, 2, 4, 7, 14 and 28. So basically it is not only about a 6, 12 or 28. It becomes any number, and if I ask you to find out its factors, you will be able to do that. In fact, we have learned a few methods to find out factors. For example, if you want to find out the prime factors, you can do prime factorization of a number, right? So we have already done factorization of numbers. Basically, you know how to find out factors of a number. So what are we going to do in this lesson? This lesson is going to be something different and new. So in this lesson, we are going to deal with the algebraic expressions. Now, wherever it comes to expressions, these are not only a numbers, but they are variables also, such that they are operations and they are including numbers also, right? Now 6xy, it's an expression, right? 22y minus 33z, it's also an expression. 5x square y minus 15xy square is also an expression, isn't it? So if I ask you to find out the factors of these expressions, will you be able to do that? No need to do right now because I didn't taught you how to do that, right? So that is what our topic is in this lesson. Okay? That means how do we factorize algebraic expressions? So factorization of algebraic expression, here also factorization would mean the same. It means finding factors. Simple meaning, finding factors. So let us look at this simple algebraic expression. So this is a monomial because in this expression you have only one term, means 6xy, isn't it? So this is our monomial. So how can you write a 6xy? Look, basically what is 6xy? 6xy is nothing but 6 into x into y. So basically 6xy can be written as a product of these three things: 6, x and y. So what are these 6, x and y? These are the factors of the algebraic expression of 6xy, right? Why are they factors? Because these are the numbers which one multiplied together gives you this number. Exactly how it happens, let's see. When we talk about a number like let's say 4. So what are the factors of 4? 1, 2 and 4. Why? Because 1 into 4 is 4, can be written as 1 into 4. 4 can also be written as 2 into 2. 4 can also be written as 4 into 1. So 1, 2, 4, these are factors of 4 because you can write 4 as the product of those two numbers, or in other ways you can say that these numbers are exactly divisible of 4. So in this case also the same thing, whether we talk about 6 or you talk about x or you talk about y. Each of these are exactly divisible of the given expression 6xy, right? So 6x and y are the factors of 6xy. But it was pretty simple. What about a complex expression like 22y minus 33z or 5x square y minus 15xy square, or like a raised to 4 minus 2a square b square plus b raised to 4. Even more complex examples of p square plus 6p plus 8. So you might come across many other more complex algebraic expressions. So let us learn different methods to factorize expressions. Okay. So, these are the various methods of factorization. Method of common factors, method of regrouping, factorization using identities, factors of the form x plus a into x plus b. So, these are the four ways of factorizing algebraic expressions. Let's learn them one by one. So, first we will learn type 1, that is method of common factors. Let us try to understand the method of common factors using an example. Here you have taken a very simple algebraic expression, that is 12x plus 36. So what do we do? So our first step would be to write each term as a product of irreducible factors. Irreducible factors means factors which cannot be reduced further. For example, if it is xy, it can be reduced further as x into y. But when it comes to x, x cannot be reduced further, right? So we have to write each term as a product of irreducible factors. So what are the terms in this expression? One term is 12x and the other term is 36. So let us first write 12x as irreducible factors. So 12x can be written as 12 into x. Now 12 can be further written as 2 into 2 into 3. Right? That is how we do prime factorization. So this becomes 12x can be written as 2 into 2 into 3 into x. In a similar way, let us write 36. So 36, if you factorize it, you will get it 2 into 2 into 3 into 3. Right? So that is our step number 1. Step number 2 is applied distributive law. So basically once you have factorized it, in this can be written somewhat like this. So instead of 12x, you can write it as 2 into 2 into 3 into x, plus 36 can be written as 2 into 2 into 3 into 3. So now we will try to apply distributive law. So, do you remember distributive law? It says that A into B plus C is equal to A into B plus A into C. This is the distributive law. So, how can we apply distributive law in this case? So if you look at closely, this 2 into 2 into 3 is common for both the terms, right? So basically 2 into 2 into 3 is behaving like our A. This x is behaving like b and 3 is like our c. So basically this equation is of the form into b plus a into c. So what is a into b plus a into c? This is equal to a into b plus c. So you can write it as a into b plus c. So this is what 2 into 2 into 3 into x plus 3. That means 2 2 are 4, 4 3 are 12. 12 into x plus 3. So this 12 into x plus 3 is the factor form of this expression. So if you look at this expression is how many terms? This expression has two terms. One is 12x and the other one is 36. But when you look at this expression is only one term. And what are the factors? 12 is one factor and x plus 3 is the another factor. So this is the factorization of this expression 12x plus 36. Right? So in this way we can factorize the given algebraic expression. So step 3 is irreducible factors are obtained. So let us try out a few more examples of method of common factors. So here you are given 22y minus 33z. So here our first step is to factorize both the terms. Right? So the first term is 22y. This can be written as 2 into 11 into y. The second term is 33z. This can be written as 3 into 11 into z. Okay. So, therefore, we can write 22y minus 33z as 2 into 11 into y minus 3 into 11 into z. Now, look at this. These two. You have anything in common? Yes, we have 11 in common, right? 11 is common in both of these terms. So, 11 is behaving like our A. That is A into B plus A into C. So, in this case, it can be A into B minus A into C. So, this can be written as A into B minus A into C. So, here would be 2y is left and 3z is left. So, 11 into 2y minus 3z. So, this is the factor form of the given expression. Right? Let us try one more. 14pq plus 35pqr. So, again step 1, 14pq can be written as 2 into 7 into p into q. 35pqr can be written as 5 into 7 into p into q into r. Right? Step number 2, we can write 14pq plus 35pqr as 2 into 7 into p into q plus 5 into 7 into p into q into r. Right? So what is common in both? 7pq is common in both of these two terms. Right? Therefore, in step number 3, what do? We will apply the distributive law. It is 7 into p into q. So what is left inside? 2 plus 5r. So the factor form of this expression is 7pq into 2 plus 5r. So this way we can factorize an expression by the method of common factors. Clear? Now, let us try to do type 2, that is method of regrouping terms. So what do you mean by regrouping terms? So basically we have multiple terms in an expression and we group that terms based on common factors. Based on which would terms, which would terms here more in common, we group them together. Let us take one example. So here we have 15xy minus 6x plus 5y minus 2. So there are total 4 terms in this expression, right? So our first step would be regroup the terms such that terms with the common factors are together. So in this case, looking at these 4 terms, Can you tell me which terms are have more common factors? So if you compare 15xy with the 5y, so here 15xy is 5 into 3 is 15, right? So that means 15xy is has more in common. So these two have more in common. Similarly, 6x and 2. 2 into 3 is 6, right? So 2 is a common factor of both the cases. So 6 and 2 have more in common. So let's put these two terms put together. Let's put these two terms together. This is the most important steps in this method. So this can be written as 15xy plus 5y minus 6x minus 2. So this is how we can write this. Okay. Now this is the first part of the expression. So we will solve the first part of the expression exactly the similar way as we did in the type 1. That is factorization, method of factorization by common factors. So write both of these terms in their factor form. Write the factors of each term. So 15xy can be written as 3 into 5 into x into y plus 5y can be written as 5 into y. Right? Similarly, 6 can be written as 2 into 3 into x and 2 can be written as 2 itself. So now first here 2 into 1. Okay. So now first compare these two terms. So these two, what is in common between these two terms? 5y is common. Right? So 5y we have taken as a common. Then what is left inside? 3x. Because 5y we already taken out. So 3x is left. And for the second term only 1 is left. So this would be 5y into 3x plus 1. Similarly, these two terms, if we compare, what is common? 2 is the common thing. So if you take 2 outside, what would be then inside the bracket? Here we have given some special attention because minus sign here we are taking minus sign as a taken as a common. Not only 2, we are taking minus sign also as a common. So minus 2 into how much would be given? Minus 2 into 3 into x, that is minus 6x. Obviously, plus 3x is remaining there. So, minus 2 into plus 3x gives you minus 6x. Similarly, minus 2 into plus 1 gives you minus 2. If you put a minus sign outside, then inside the sign will change as a plus. Now, if you compare this term with a minus 2 into 3 into x and minus 2 into 1, anything is common? Yes, minus 2 is common and inside 3x plus 1 is remaining. Now 5y into 3x plus 1 plus 2 into 3x plus 1. We compare these terms 5y into 3x plus 1 and minus 2 into 3x plus 1. Then anything is common? Yes, 3x plus 1 is common. Right? Now what are we left with? 5 minus 5y minus 2. Right? So what is become the first term? We have taken 3x plus 1 as a common factor that we have taken up. So what is left? 5y in the second term. Also the common factor 3x plus 1 we have taken out. Then what is left? Minus 2. So 5y minus 2 left out. So 3x plus 1 into 5y minus 2. This is the factor form of the given algebraic expression. Clear? So let's try another example. By the same method of regrouping, so here you have it ax plus bx minus ay minus by. So can you group the terms in such a way that they have more common factors? So if you let these four terms here, you would see that ax and ay they tend to have common factor, which is A, right? Similarly, Bx and By, they would have common factor B, right? So, how would it be if we know, try to group them together. Now, there could be another thought come into our mind that why can't we group X and Bx together? Because they also have X common. That because you have to think a little bit this time, right? So if you take x common, you will be left out a plus b. In this case, if you take minus y common, you will be left out a plus b. So that is also fine. It's up to your choice. In which way, means which way you want to do. Okay. If you follow these both ways, we will reach the same answer. Okay. So let's opt the first option, group A x plus bx together and bx and by together. So if you write each term in the form of its factor, that is, it can be written as a into x minus a into y plus b into x minus b into y. So what are the common factors you would have? That is, a is the common factor and you left with x minus y. Here b is the common factor and x minus y again left here. Now if you compare these two terms, what would you have common? You have x minus y common, right? So what are you left with? You left with a plus b. So x minus y into a plus b. This is the factor form of the given expression. Can try out, that is, means you can try out this again. That is, if we regroup instead of ax and by, we can regroup ax and bx. And same way minus ay and minus by. In this case, common x into a plus b and second term minus y into a plus b. Here minus also taken as a common. Okay. So inside sign will change as a plus. Now again see the common factors, that is a plus b. So what can be, means what are the things left out here? That is x minus 1. Both the case the answer is same. Right? Yes, the result is same only. Both answers are same. That is a plus b into x minus y. Yeah, x minus y into a plus b. So this is our factorization by regrouping. So let me start our exercise 14.1. Question number 1. Find the common factors of the given terms. So how could we find the common factors? We factorize each term of the given algebraic expression as a product of irreducible factors and separate the common factor, right? Same way what we have done in arithmetic progression. Okay. So first question is 12x and 36. This one we already done, right? 12x and 36, the factors we already taken. 2 into 2 into 3 into 6, that is 12x. And 36, 2 into 2 into 3 into 3. Then what are common here? Here the common factors, here common numbers are, here common terms are 2 into 2 into 3. That means 2 2 are 4, 4 3 are 12. So the common factor of 12x and 36 is 12. Clear? Second one, 2y and 22xy. 2y. The factors of 2y are 2 into y. Then the factors of 22xy is 2 into 11 into x into y. So what are common here? 2 and y. So the common factors of 2y and 22xy is 2 into y. That is equal to 2y. Clear? Third one, 14pq 28p square q square. 14pq is equal to the factor of 14, 2 into 7, p into q. 28p square q square, 28, 2 into 2 into 7 into p square means p into p, q square means q into q. So what are common here? 2 into 7 into p into q. That is common in both. So what is the common factor? That is 2 7 are 14, p into q, pq. So 14 pq is the common factor of 14 pq and 28 p square q square. Right? Now fourth one. 2x, 3x square and 4. 2x means 2 into x. 3x square means 3 into x into x. 4 means 2 into 2. Here anything is common? We need any number in all the three terms. Any number is there? No. X is there in first and second term. 2 is there in first and third term. Right? So nothing is common means only 1 is common. Why 1 is common? 1 is a factor of every number, isn't it? So here common factor is 1. If 1 is multiplied with any number, we will get the same number. So that is why 1 is the common factor of every number. Yeah, 1 is the factor of every number. So what is the answer? The common factor of 2x, 3x square and 4 is 1. Now question number 5. 6abc, 24ab square, 12a square b. 6abc, that is 2 into 3 into a into b into c. 24ab square, 2 into 2 into 2 into 3 into a into b square means b into b. 12a square b, 12 2 into 2 into 3 into a square, a into b. So what are common here? 2, 3, a, b. These are common, right? So common factors are 2 into 3 into a into b. That means 2 3 is 6, a into b, ab. So 6ab. So 6ab is the common factor of 6abc, 24ab square and 12a square b. Okay. Now question number 6. 16x cube minus 4x square 32x. 16x cube means 16. 2 into 2 into 2 into 2. X cube means 3 times x. X into x into x. Minus 4x square. That means minus is common for all. 2 into 2 into x into x. Now 32x. 2 into 2 into 2 into 2 into 2 into x. Now what is common? Common factors are 2 into 2 into x. That means 2 to the 4. 4x is common. The sign minus sign is not common. So only 2 to the 4. 4 into x. 4x is common. Okay. Now question number 7. Question number 7. 10PQ, 20QR, 30RP. So here 10PQ, that is 10 2 into 5, P into PQ. 20QR, 20, 2 into 2 into 5 into Q into R, QR. 30RP, 2 into 3 into 5 into R into P. So here what are common? Only 2 and 5 is common. That means common factors are 2 into 5. That is equal to 10. So 10 is the common factor of 10PQ, 20QR, 30RP. Okay. Now 8 1. 3x square y square, 10x cube y square, 6x square y square z. So here 3x square y square is equal to 3 into x into x into y into y. 10x cube y square means 2 into 5 into x into x into x into y into 2 into 3 into means that means 6x square y square z. That is equal to 2 into 3 into x into y into z. Okay. So what are common here? Here only common factors are x into x into y into y. So the common factors of 3x square y square, 10x cube y square, 6x square y square z is x square y square. Clear? Now, question number 2. Factorize the following expressions. So, first question is 7x minus 42. What do you mean by factorization? Factorization means to find factors, right? So, here the factors of 7 is 7 into x and factors of 42 is 2 into 3 into 7. Now we can find the common factor of both. What is common here? 7 is common. So that we can take out. So what is left inside? X and minus 2 3 is 6. So what is the factor? 7 and x minus 6. So 7 into x minus 6 is factor form of 7x minus 42. Okay. Now second one. 6p minus 12q. Here 6p can write as 2 into 3 into p. Here directly 6 into p also you can write. Minus 12q can be write as 2 into 3 into 2. Yeah, 2 into 2 into 3. Yeah, 6 into 2 into q. So here we can see that 6 is common for both. Right? So 6 can be taken out. Then what is left out? P minus 2q. So that is the factor form. 6 into P minus 2q. Okay. Third one. 7a square plus 14a. Here 7a square can be written as 7 into a into a. 14a can be written as 2 into 7 into a. So here you can see that 7 and a both are common for both the cases, both the terms, right? So 7a can be taken out. Now what is left out there? A plus 2. So the factor form is 7a into a plus 2. Fourth one, minus 16z plus 20z cube. Minus 16 can be written as minus 4 into 4 into z. Yeah, otherwise 2 into 2 into 2 into 2. Okay, plus 20 can be written as 2 into 2 into 5. Yeah, 4 into 5 into z into z into z. Here you can see that 4z is common for both the case. So that we can take as common factor and take outside. So 4z is outside, then what is left out? Minus 4 in first term and plus 5z square in second term. So the factor form is 4z into minus 4 plus 5z square. Right? Now fifth one. 20l square m plus 30al m. So 20 can be written as 2 into 10 is 10. 20, right? 10 can also you can write it 2 into 5. Yeah, otherwise 2 into 2 into 5 that is equal to 20. Into L into m. 30 can be written as 3 into 10, yeah, otherwise 3 into 2 into 5. Okay. Into A into L into M. So here 10 is common and L and M also common in both the terms. So we can take 10 M, L outside. Now what is left inside? 2L plus 3A. Okay, so the factor form of 20L square M plus 30ALM is 10LM into 2L plus 3A. Now sixth one, 5x square y minus 15xy square. 5x square y can be written as 5 into x into y. Minus 15xy square can be written as 3 into 5 into x into y. Now see what is common here in both the terms. 5xy is common. So that we can take out. Then what is left out? Here first term x is left there. In second term 3y is minus 3y is left there. So what is the factor form? 5xy into x minus 3y. Now seventh one. 10a square minus 15b square plus 20c square. So factorize all three terms. In this case, three terms are there. So first term 2 into 5 into a into a minus second term 3 into 5 into b plus 20c square can be written as 2 into 2 into 5 into c. Okay. So here in all three cases we can see that 5 is common there. So that 5 we can take out as common. And inside what is left out there? First 2a square minus second term 3b square plus third term 4c square. So this is the factor form. 5 into 2a square minus 3b square plus 4c square. Okay. Now question number 8. Minus 4a square plus 4ab minus 4ca. So here minus 4a square can be written as minus into 2 into 2 into a plus 4ab can be written as 2 into 2 into a into b and minus 4ca can be written as minus into 2 into 2 into c into a. Now let's see what is common here. Here we can see 4a is common, right? So 4a can be taken out. Now what is left out? Minus a in first term plus b in second term and minus c in third term. So what is the factor form? 4a into minus a plus b minus c. Right? Now ninth one. X square yz plus xy square z plus xyz square. So x square yz can be written as x into y into z plus xy square z can be written as x into y into z plus xyz square can be written as x into y into z into z. Now see what is common here. X, y, z is 1 times. It is common in all the 3 terms, right? So we can take out x, y, z. Now what is left inside? X plus y plus z. So what is the factor form? X, y, z into x plus y plus z. Right? Now 10th one. Ax square y plus bxy square plus cxyz. First factor form of ax square y is a into x into x into y. Bxy square can be written as b into x into y into y. Cxyz can be written as c into x into y into z. Now here what is common in all the case? Xy is common, right? So that we can take out. Now what is left inside? In first term, ax is left out. Second term, by and third term, cz. So what is the factor form? Xy into ax plus by plus cz. That is the answer. Okay. Now, let's see question number 3. Factorize. You can see that in question number 2, we have done type 1. That means method of common factors for finding factorization, right? But here we are using type 2. That is method of regrouping. So here first question is x square plus xy plus 8x plus 8y. So here in both the case means if we group same way, we will get common factors there. So that is why we are regrouping like this. First group is x square plus xy and second group is plus 8xy plus 8y. Okay. In first group we will get x is common and x plus y is left out inside. Same way second group plus 8 is common, x plus y is remaining there. So now again you can see that x plus y is common there. So that again we have taken out as a common factor. So x plus y and what is remaining? X plus 8. So this is the factor form of the given expression. So the required factors are x plus y into x plus 8. Clear? Same way question number 2. 15xy minus 6x plus 5y minus 2. This question we already done as an example. Remembering? But here we are doing in another way. Means there we have regrouped 15xy and 5y together. But here we are doing same. Whatever is given. They are only regrouping. 15xy and minus 6x we are keeping one group. And 5y minus 2 we are keeping another. Okay. So first by regrouping we will get 15xy minus 6x plus 5y minus 2. So here first one 15 and 6 we know that 15 can be written as 3 into 5. Same way 6 can be written as 3 into 2. So 3 is common there. Right? And xy and x. So x is common there. So 3x can be written as common and what is left out? 5y minus 2. Plus in second case nothing is common. So we can take 1 as a common. So 1 is the factor of every number. So 1 we have put as a common. Now inside 5y minus 2. Now again you can see that 5y minus 2 is common for both the cases, right? So 5y minus 2 we can take as common. Now what is left out? 3x plus 1. So this is the factor form. Means the required factors are 5y minus 2 into 3x plus 1. Now third question. Ax plus bx minus ay minus by. This question also we already done. Both the ways we have done, right? So quickly we can do. So regrouping we will get ax minus ay plus bx minus by. So here a is common in first case or x minus y is left out. Second case b is remaining as a common and x minus y is inside. So now you can see that x minus y is common there. So that taken out. So x minus y is there. One factor and what is left out? A plus b. So a plus b is the another factor. So the required factors are x minus y into a plus b. Clear? Now fourth one. 15p cube plus 15 plus 9q plus 25p. Here by regrouping, we are taking 15 PQ and 25 P together. Because in 15 and 25, we know that 5 is common there. PQ and P is common there. Right? Same way 9Q and 15. So 9 and 15, we know that 9 can be written as 3 into 3, 15 can be written as 3 into 5. So there also 3 is common. Right? So now we will get a 5P as common and inside left out 3Q plus 5 in first group. And in second group, 3 we have taken as common, then remaining 3Q plus 5 inside. So 3Q plus 5 is again common here, that we have taken out. Then remaining 5P plus 3. So the required factors are 3Q plus 5 into 5P plus 3. Clear? Now next question number 5. Z minus 7 plus 7xy minus xyz. Here by regrouping, we are taking first z and minus xyz together. Minus 7 plus 7xy together. Okay. So here from first group, z can be taken as a common. Now what is left out? 1 minus xy. Now here we are taking minus 7 is common. So what is left out? Inside 1 is there and sign also you have to see. Minus 7 we have taken. So inside again minus sign will be there. Then only minus into minus a plus will come. So minus 7 we already taken out. So now minus xy is remaining there. Now again 1 minus xy is common there. So that we can take. Now what is left out? Z minus 7. So that is the factor. 1 minus xy into z minus 7. Clear? Here we are winding up this session. So we have completed introduction part 1 with a detailed explanation of factorization and method of factorization of two types, that is method of common factors and a method of regrouping. And with that we already solved exercise 14.1 all three questions. So note down all the things in your notebook neatly. So thank you.